Hello, my name is Kiran Kumar. I am a physics lecturer. Today topic is lateral displacement, its applications. Please watch my part 1 video in this lateral displacement through a rectangular glass slab. Now this is the applications of lateral displacement part 2 video. Welcome to my channel Nature of Physics and Art. Now I will discuss the lateral displacement applications. PQRS is a rectangular glass slab and AO incident ray and OB refracted ray and BD is emergent ray. When light traveling from a rarer medium to denser medium, it bend towards the normal. So when I is the angle of incident, R is the angle of refraction, here del is the angle of deviation and small d is the lateral displacement. Now lateral displacement equation already we did in the previous video part 1. Please watch that video for the proof. Now d, which is equal to T divided by cos R sin I minus R. See, for very small angles, here sin I approximately equal to I sin I minus R is approximately equal to I minus R, and cos R, which is equal to 1. Because of, please try to understand, we can discuss one of the example. If theta is equal 0, here sin 0, which is equal to 0, and cos 0, which is equal to 1. This is theta 0. Approximately we can consider a very small angle. For this I we can consider very small, then cos R value, which is equal to 1. These values are replacing in the above equation. Now the resultant equation for the lateral displacement D, which is equal to T divided by cos R is 1 and sin I minus R, which is we can write I minus R. Okay, so D, which is equal to T into 1 minus R by I. Here I is common. Try to understand. Here you know Snell's law. So according to the Snell's law, mu is equal to sin I by sin R. For very small angles, here mu, which is equal to sin I is written as I, sin R is written as R. Since you can write here sin I is approximately equal to I and sin R, which is approximately equal to R. Now we got mu is equal to I by R. This equation is replacing in the above equation. Then D, which is equal to T into 1 minus, here I by R replacing, that is I by R into I. Now D, which is equal to T into 1 minus 1 divided by I by R is a refractive index of the glass slab into I. This is the lateral displacement equation in terms of thickness, refractive index and angle of incident of the rectangular glass slab. Okay. Now the angle between the lateral displacement B and angle of incident I. See, on the x-axis angle of incident I, and with respect to y-axis considering lateral displacement. Here this is like a parabola. Here the value is maximum, that is theta, that is I value. pi by 2 90 degrees. Here corresponding d value is taken as t. T is the thickness of glass slab. The proof we will discuss based on the according to law of optical refractivity. Light traveling from the rarer medium to denser medium. Here I is the angle of incident, R is the angle of refraction. Light can also travel from the denser medium to rarer medium. In this situation we can consider R is the angle of incident, I is the angle of refraction. According to the law of refraction, here this path is same for the whenever light travel from the rarer medium to denser medium and denser medium to rarer medium. For the same considering for the critical angle. See now light traveling from the rarer medium to denser medium. Here the incident ray is perpendicular to the normal, that is 90 degrees, and light traveling from the rarer medium to denser medium. That's why here angle of refraction which is equal to critical angle. Angle of refraction which is equal to critical angle. Whenever light traveling from the denser medium to rarer medium, angle of incident which is equal to critical angle, angle of refraction is 90 degrees. Here we are applying the optical law of refractivity. Based on that we will discuss the here same equation, lateral displacement. See d which is equal to t divided by cos r sin I minus r. Here try to understand the values step by step. Now taking here cos r value and sin I minus r values. See here I is equal to pi by 2, that is equal to 90 degrees, and r is taken as c. These values are replacing in the above equation. D which is equal to t divided by cos r and sin 90 minus c. Here d which is equal to t divided by cos r. This sin 90 minus c is cos c. But we know r is equal c. That's why both values will be get cancelled. So now the resultant equation t is equal d, and here I is equal to pi by 2. See in the graph here on the x-axis angle of incident and y-axis lateral displacement. Whenever angle of incident is 90 degrees and lateral displacement which is equal to thickness of the glass slab. Okay, next application we can discuss continuously. Another method to find the relation between the T and the D. D is the lateral displacement, T is the thickness, and also sine angle of incident. Try to understand the relation. We know the relation D is equal T divided by cos R sin I minus R. Here sin A minus B formula applying. So D which is equal to T divided by cos R sin I cos R minus cos I and sin R. See here denominator value cos R is multiplied, D which is equal to T into sin I, cos R value is get cancel, minus cos I sin R divided by cos R, and here sin I value is common. See D which is equal to T into 1 minus cos I sin R divided by cos R and sin I. Sin I is common. Try to understand here, and we are applying the Snell's law. That is according to Snell's law, here mu which is equal to sin I divided by sin R. Rearranging this equation, D which is equal to T into 1 minus sin R. 1 minute. here cos I divided by sin I divided by sin R into cos R into the remaining value is sin I. Okay, see now here mu which is equal to sin I by sin R, the value is replacing d which is equal to t into 1 minus cos I divided by here mu into cos R into sin I value. Okay, so try to understand here cos R which is equal to root over 1 minus sin square R. Again using the Snell's law, mu is equal to sin I by sin R. From this equation sin R which is equal to sin I divided by R, mu value. Okay, so this value is replacing in the above equation. So cos R which is equal to root over 1 minus sin square I divided by mu square. Take a LCM. So here cos R which is equal to root over mu square minus sin square I whole divided by mu square. Now resultant equation cos R which is equal to mu square minus sin square I whole divided by mu. For this denominator value mu square square root of get cancel. We got the cos R value that is replacing in this equation, that d which is equal to t 1 minus cos I divided by mu into cos R value is root over mu square minus sin square I whole divided by mu into sin I. Try to understand, mu get cancel, then the resultant equation d which is equal to t into 1 minus cos I divided by root over mu square minus sin square I into sin I. Okay, so here we can replace the even cos I also. What is the cos I? Which is equal to root over 1 minus sin square I. Now d which is equal to t into 1 minus root over 1 minus sin square I divided by root over mu square sin square I into sin I. This is the one of the equation. See, for very small angles, we can write that is if theta is approximately equal to 0, then sin 0 is equal to 0, and sin I is approximately equal to I, and the resultant equation d which is equal to t into 1 minus this value is numerator 1 divided by denominator mu square square root of is get cancel, that is into sin I value which is equal to I. So this is already we did, this is second equation only. From second proof also we got the relation between the lateral displacement and thickness of the glass slab. Now one problem based on the lateral displacement. A light ray from air is incident on a glass plate of thickness t and a refractive index mu. An angle of incident is equal to the angle of total internal reflection of glass. Compute the displacement of ray due to this plate in terms of thickness and refractive index of glass mu is. See, here already we did that d which is equal to t into sin I minus cos I sin R divided by cos R. So sin I minus cos I, this sin by cos is tan, that is tan R. See, that is according to the question given here, sin C, which is equal to 1 by mu. Here that question, here I is equal to C. That's why angle of incident for this angle of refraction is 90 degrees. Now I value replacing in this equation, so sin I, which is equal to 1 by mu. See, now based on that we can find the cos I value. See, this is the triangle, this angle of incident I, okay, and this is opposite side is 1 and adjacent side is mu according to the given equation, and this value is mu square minus 1. Now we can get the cos I. What is the equation for cos I? That is adjacent side divided by hypotenuse. See that adjacent side is root over mu square minus 1 divided by mu. This is the value for sin I and cos I. We need to find the tan R. For this, considering Snell's law. See now, mu, which is equal to sin I divided by sin R. Try to understand. In this equation, we are writing sin I, which is equal to 1 by mu, and the resultant equation, that is equal to mu into sin I value is 1 by mu divided by sin R. Okay, so now sin R, which is equal to 1 by mu square. We got sin R value, which is equal to 1 by mu square. Again, based on the refractive angle, we can find the cos value also. See, considering a triangle, this is the refractive angle R value. See now, this is R, and sin R value, which is equal to 1 by mu square. So now this adjacent side value is mu to the power of 4 minus 1. So we can write the here tan R value. So here tan R, which is equal to tan R opposite divided by root over mu to the power of 4 minus 1. Totally we got the three equations, required equations, sin I value, cos I value and tan R value. These values are replacing in the above equation. Then the resultant equation, see here d, which is equal to t into sin I minus cos I into tan R. See, in this equation, d, which is equal t into sin I value is 1 by mu and cos I value, which is root over mu square minus 1 whole divided by mu into tan R value is 1 divided by root over mu to the power of 4 minus 1. See, try to understand, mu value is common here. Now d, which is equal to t divided by mu, that is 1 minus root over mu square minus 1. Rearranging the equation in denominator, that is equal to root over mu square minus 1 into root over mu square plus 1. So here mu square minus 1 square root of value in denominator, mu square minus 1 root over value get cancelled. Then the resultant equation d, which is equal to t divided by mu 1 minus 1 divided by root over mu square plus 1. This is the equation for the given question. This is the relation between the lateral displacement, thickness and refractive index of the glass slab. Thank you very much.